Let's meet the stars of similitude, the non-dimensional numbers that engineers rely on every day. First up, the Reynolds number. This number is all about the balance between inertial forces and viscous forces in a fluid. It tells us whether the flow will be smooth and orderly, what we call laminar, or chaotic and swirling, which is turbulent flow. If you match the Reynolds number between your model and the real thing, you'll see the same flow patterns, laminar or turbulent, no matter the size. That's why wind tunnel tests for airplanes are so powerful. Next, let's talk about the Froude number. The Froude number is crucial for flows where gravity is the main player. Think of waves around ships, boats, or even river flows. By matching the Froude number, engineers make sure the waves created by a model ship in a tank look and behave just like those around a real ship at sea. And for high-speed flows, especially when things start moving faster than sound, we need the Mach number. The Mach number is critical for studying supersonic aircraft, rockets, and even explosions, because it tells us how fast something is moving compared to the speed of sound. By matching the Mach number in wind tunnel tests, engineers can observe shock waves and pressure changes, just like those experienced by real jets in flight. There are other important players too, like the Weber number, which is all about surface tension and helps us understand how droplets form and break apart. Or the Strouhal number, which is key for studying vortex shedding. Think of the vibrations in bridges or the way droplets detach from surfaces. Each number unlocks a different engineering mystery. By matching these non-dimensional numbers, engineers can accurately predict how planes will fly, how ships will sail, or how dams will handle floods, all without building the full-scale version first. It saves time, money, and even lives. But here's the catch. Matching all the important numbers at once, like Reynolds and Froude, is really tough because they don't always scale the same way. It's a real engineering puzzle. That's why engineers often prioritize the most critical number for their problem, like Froude for ships or Reynolds for pipes, and use creative tricks, like changing the fluid or adjusting the model to get as close as possible. It's not a perfect science, but with experience and ingenuity, it works remarkably well. Non-dimensional numbers are truly the unsung heroes of engineering, quietly making breakthroughs possible behind the scenes. Thanks to these numbers, we can shrink the world, test our ideas, and make discoveries that change how we build and move. If you're fascinated by the science of fluid mechanics and want to dive deeper into the world of engineering, there's so much more to explore. Drop a like, hit subscribe, and let us know in the comments which non-dimensional number you think is the coolest. Reynolds, Froude, Mach, or maybe another. Thanks for watching, and see you next time for more engineering secrets.